Hi everyone, welcome back. The next topic is the torque equation, the developed torque equation of an three-phase induction machine, that is induction motor especially. So normally an induction motor, the developed torque which is depends on some of the factors. So there are three factors. The first factor based on the flux, based on the flux which is responsible to induce the EMF. The next one, the magnitude of rotor current under running condition. The magnitude of rotor current. Okay. And third one, the power factor of the rotor circuit under the running condition. So based on these three factors only, the torque which is produced or the torque which is developed in the motor gets depend. Okay, so here the mathematically the torque equation can be written as the torque is directly proportional to flux. So the flux is which is responsible to produce the EMF. So when we are cutting the flux, so that only the EMF will be induced. So based on that only the torque will be induced in the motor. So the torque is directly proportional to flux, and I2R. The I2R is nothing but rotor current under running condition, rotor current under running condition. And next one, cos pi. Cos pi is nothing but power factor, and the 2R it represent the that is running power factor of rotor, the power factor of the rotor under running condition. So therefore the torque equation which is equal to which is directly proportional to flux, rotor current, and power factor of the rotor. So the next, so the flux which is produced by the stator, it is due to the stator supply voltage. It is due to the stator supply voltage. So the flux produced inside the machine which is directly proportional to the supply voltage E1. But according to the transformation ratio, so the E2 by E1 is equal to K. E2 by E1 is equal to K. So here the ratio of induced voltage in the rotor to the induced voltage in the stator which is equal to K. This is called transformation ratio of the induction machine. So by using this relation, if E2 is equal to K and E1 is equal to K, if both are same constant only. So if E1 is directly proportional to pi, means the E2 is also depends on the pi. If the flux is changes, the induced voltage in the rotor is also gets changes. Okay, so therefore E2 is directly proportional to pi. Okay, so now, so next I2R, the rotor current under the running condition. So general formula, I is equal to V by Z. V by R in DC, and AC it is V by Z. So instead of V, we can written as E, induced EMF E, that is called E by Z. So E is nothing but the induced voltage in the rotor, because I2R, that is only the current in the rotor. So therefore the induced EMF in the rotor divided by the impedance in the rotor. So the E2R can be rewritten as slip into induced voltage E2 divided by the Z is equal to impedance is equal to root of R2 square plus S into X2 whole square. Okay, and next the power factor. So according to the power factor is equal to R by Z. The power factor is equal to R by Z. The power factor of the rotor. So therefore, so this is rotor resistance, and this is impedance is also in the rotor side. So so R2 divided by Z2R. So impedance is nothing but combination of resistance and reactance. So therefore root of R2 square plus S into X2 whole square. Okay. So now we can know the flux is directly proportional to E2, and we know the value of I2R, and we know the value of cos pi 2R. Now we can substitute all those here. So now we are getting the torque is directly proportional to, instead of flux we are putting pi E2, and instead of current I2R we are substituting, and instead of power factor we are substituting here. So by substituting the values flux, rotor current, and power factor of the rotor, we are getting this one. So by simplifying these equations, we are getting the final equation, the torque is directly proportional to S into E2 square R2 divided by R2 square plus S into X2 whole square. Now, by cancelling the proportional and we are multiplying the constant K. Okay. So by using this equation, so the torque is which is equal to here the constant K is nothing but it can be proved it is 3 by 2 pi ns. So we are instead of K we are multiplying the 3 divided by 2 pi ns. So S into E2 square R2 divided by R2 square plus S into X2 whole square. So the developed torque. Okay, so here the induced voltage in the rotor, it depends on the flux, and R2 is constant, X2 is also constant. So here the developed torque is mainly depends on the slip. If the load is changes, the speed will change. If the speed is changes, the torque will change. And this is the starting torque. So at initially at that time, according to the slip equation, S is equal to synchronous speed minus actual speed divided by synchronous speed. At initially the speed is 0, so therefore ns by ns it getting 1. So S is equal to 1. So by multiplying the value of S, we are getting the starting torque. Okay, now S will be there because instead of this S, it will be denoted as it will be substituted as 1. So the S will be eliminated because S is 1. So we are getting the starting torque. This is the starting torque of an induction machine. And next assessment. So what is the value of slip at the time of starting of induction motor? So put your answer in the comment section. And these are the few references. Thank you.